In this lesson, we're going to look at simplifying square roots. And this is something that takes some skill and takes some time to develop that skill. So I hope that you'll be patient with yourself and that you'll just keep working on it. It's something that you may be slow at first, but your speed and your skill will develop the more you do it. It's a lot like learning to cook or learning to drive. You have to learn your own ways of doing things so that you don't have to figure everything out every time. So let's get started. First of all, what we mean by simplifying square roots is to leave the smallest number possible under the radical. We want absolutely no perfect squares left under the radical. So one thing we use when we're simplifying is we use the product rule for radicals. And let me show you what that means. It means that if I have the square root of x times the square root of y, it can be written as one big radical where I have x times y under the radical. Now usually when we're simplifying, we're going from a big multiplied number to two smaller numbers in their own separate radicals. So we're actually using the rule backwards to simplify. And here it is backwards. If I have a big number under the radical, I can split it up into factors, and each factor can get its own radical. So let's simplify the square root of 8. So usually a good thing to ask yourself is, do I know of any perfect squares that go into 8? And what I mean by perfect squares is like 2 to the second is 4, 3 to the second is 9. Will 4 or 9 or 16 or 25 go into this number under the radical? And in this case, the answer is yes. 4 will go into 8. So I can write this as 4 times 2. Now the product rule says, you remember, that if I have a product under the radical, I can split it up so that each factor has its own radical. Then I know the square root of 4 is 2. But this square root of 2, I cannot simplify because the square root of 2 is not a whole number. The square root of 4 is 2. But the square root of 2 cannot be simplified, so that stays the way it is. And this is a simplified radical because what's under the radical does not contain a perfect square factor. Let's do another one. Alright, just a reminder that it helps if you can break this down into a perfect square times something else. Okay, here's 75. Let's try to think. Will 4 go into this? No. Will 9 go into 75? No. How about 16? No. How about 25? See, I'm trying all the squares. Well, yes, 25 will go into 75. In fact, 75 is 25 times 3. Now I'm going to use the product rule to break this into two separate radicals. It's square root of 25 times square root of 3. Then square root of 25 is a perfect square radicand, so this can be simplified. Square root of 25 is 5. And the square root of 3, of course, does not have a whole number square root, so it stays in that radical form. And here's another example. The square root of 24. Now ask yourself, are there any perfect squares that will go into 24? And the answer is yes. The square root of 24 can be thought of as square root of 4 times 6, because 4 is a perfect square that goes into 24. Now split it up into two radicals, and the square root of 4 is 2, and 6 will not simplify, and there are no perfect squares that go into 6. So the 6 has to stay under the radical, but the square root of 4 is 2. Now if you're ever unsure, remember you do have your TI-30 calculator, so you could punch up the square root of 24, and you could punch up 2 times the square root of 6 and verify that they are the same number. So again, it's important to make sure that there are no perfect squares that go into this number you leave under the radical. If you could make 4, for example, if you could make 4 go into this, or if, say, 9 would go into this, then it would not be simplified enough. So that's important. And also, I want you to notice that it helped us split it up by choosing a perfect square times something else. Here, 12 times 2 does make 24, but this is not as easy because neither one of these is a perfect square. So I have to split up the 12 now, and 12, I guess we could do 4 times 3 would be the easiest thing. The square root of 12 is going to be square root of 4 times square root of 3. Then the square root of 4 is 2. And I have 2 times the square root of 3 times the square root of 2. But now the product rule says I can smush these back together into one radical. So 3 times 2 is 6. And I get 2 times the square root of 6. And we still get the same answer we had before, but you see that we just had more steps. So it's not that this is wrong, it's just that this is more convenient. Now let's look at a couple more examples that are similar to the last few. We've got square root of 45. So can you think of a perfect square that will go into 45? Does 4 go in? No. Does 9 go in? Yes. So let's break this down into square root of 9 times 5. Now, give each factor its own radical. The square root of 9 is 3, and the square root of 5 is not a whole number. So this is going to be 3 square root of 5. And for square root of 28, clearly 4 goes into 28, so we can think of this as the square root of 4 times 7. Then give each factor its own radical, and the square root of 4 is 2. So you get 2 square root of 7. And again, if I were you and I were just getting started, I would use my calculator to make sure that square root of 28 is the same decimal number as 2 times the square root of 7. And, that might save you some mistakes from time to time. Now, that's great for small numbers, but for larger numbers, sometimes it's harder to see how to break it up. So I have a different strategy for larger numbers. Instead of trying to see what squares will go into a number, which is difficult if the number is large, it may be easier just to factor that number down into prime factors, so that instead of looking for squares, you're looking for pairs of factors, because a pair of factors is a square, as we're about to see. Okay, here's the square root of 180. Now my first thought is that 180 can be made into 90 times 2. And my next thought is that 90 can be made into 9 times 10. Now I'm in luck because 9 is a perfect square, but 10 is not, and neither is 2. Let's keep going with the 10. I'm going to leave the 9 alone because it's a perfect square and I know what to do with it. But let's continue breaking down the 10. 10 is 2 times 5. Alright, my 10 now has been replaced by this 5 times 2. And this 2 here I've still got to get. Okay, so I had 9 times 10 times 2. Now I've got 9 times 5 times 2 times 2. It's still the same thing. But here I have a pair of 2's, which is just as good as having a 4 or a 2 squared. So now when I get ready to simplify, the 9, square root of 9 is going to be 3. And the square root of this pair of 2's is going to be 2. And the 5 is the only thing that has to stay under the radical. So the 3 and the 2 that are both outside the radical, they make 6. And I get 6 times the square root of 5. Now you need to take your calculator and verify that square root of 180 gives the same decimal number as 6 times the square root of 5. And you also need to verify that there are not any perfect square numbers that will go into what's under the radical. And in this case, of course, because it's 5, no perfect squares will go into 5. Okay, we're going to simplify another radical with a large number under the radical. And remember, the trick here is just to figure out any number at all that will go into 432. It doesn't have to be a perfect square. It's helpful if it is, but it doesn't have to be. So just anything will do. Now, you may not remember, but I want to remind you that we can tell if 4 will go into a number by looking to see if 4 will go into the last 2 digits. And since the last 2 digits here are 32, then I know 4 will go into this number. And my calculator tells me that 432 divided by 4 is 108. Therefore, 4 times 108 gives me 432. Okay, now let's keep breaking down the 108. And remember, we're either looking for a pair of factors or for a square number. So I remember that 108 is 9 times 12. So let's do that. And now I have this 9, which is a perfect square, so leave it alone. But let's try to break down the 12. Now, I happen to remember that 12 is 4 times 3. So I trade in my 12 for a 4 times 3. I had this 4 here. This 12 becomes 4 times 3. And this 9 is here. So, look what I've got now. I've got a pair of 4s. So, the square root of a pair of 4s is going to be a 4. And the square root of 9 is going to be 3. And this 3 does not have a whole number square root, so it will stay under the radical. And then I have to combine my 4 and 3 back together. 4 times 3 is 12. And you should take your calculator and make sure that the square root of 432 is equal in value to 12 times the square root of 3. Now let's simplify the square root of 648. Now you could break this down as 4 times something, because again 4 goes into 48, therefore 4 goes into the whole thing. But I also happen to notice that 9 will go into this number. So the way I knew that is 6 plus 4 plus 8 is 18. Since 9 will go into 18, 9 will go into this big number. That's a trick that only works with 3 and 9, but it does work. So over here, we could have done this as well. So 4 plus 3 is 7, and 7 plus 2 is 9. So I could have divided 9 into this number. But let's divide 9 into this number. 648 divided by 9 is 72. So what I've got here is 9 times 72 is 648. Now keep breaking down the 72. I happen to notice that 72 is 9 times 8. Now I've got a pair of 9s, and I got to break down this 8. 8 is 4 times 2. See, 8 is 4 times 2. So now I've got a pair of 9s, and the square root of that pair of 9s is going to be 9. And the square root of 4 is going to be 2. So the square root of the pair of 9s is 9. The square root of 4 is 2. And this 2 here will stay under the radical. And so we need to combine our 9 times 2 back together. And we're going to have 18 times the square root of 2. Take your calculator and verify that square root of 648 is equal in value to 18 times the square root of 2. Okay, now let's look at multiplying radicals together. We're still using the product rule, but we don't actually have to do the multiplication to multiply the stuff together. We're actually trying to break down the radical as simple as it can be. So we still need to leave everything simplified. So for example here, let's do the square root of 6 times the square root of 15. It's true that we can put these back together under one radical. The product rule says so. So I can have the square root of 6 times 15, and I could write the square root of 90 because 6 times 15 is 90. But what good would that 90 do me? Wouldn't I just turn right around and try to break down the 90? So it's already broken down. So let's leave it the way it is. Let's continue breaking down from here. So when you get a multiplication problem, put them together under one radical, but don't actually do the multiplication. Now let's break down the 6 and break down the 15. See, 6 is 3 times 2. 15 is going to be 3 times 5. Look what we've got, a pair of 3's. Now the square root of a pair of 3's is going to be 3. What stays under the radical? This 2 and this 5 are still under there. Together, 5 times 2 makes 10. So 3 times the square root of 10 is what I get when I do square root of 6 times square root of 15. Again, I've said it a few times before, you need to verify that 3 square root of 10 is the same decimal number as square root of 6 times square root of 15. Okay, here's another example. Let's do square root of 12 times square root of 54. Now the product rule says we can combine them under one radical, and the product rule would let us do 12 times 54. It would be a huge number that we'd just have to start breaking down. It's already started for us though, so don't combine these. Just continue breaking them down. Notice that both of these are multiples of 6. So let's write 12 is 6 times 2, and 54 is 6 times 9. Now I've got a pair of 6's, so the square root of this pair of 6's is going to be 6. 9 is a perfect square, so the square root of 9 is 3. And this 2 is the only thing still left under the radical. Then I know 6 times 3 is 18. So I'm going to have 18 times the square root of 2. And another one. Let's do square root of 20 times square root of 70. We do put them together under one radical. I notice that they're both multiples of 10. So let's write 2 times 10 and 7 times 10. Then I have a pair of 10's here. The square root of this pair of 10's is 10. And what's left under the radical is 2 times 7, which is 14. Okay, just a few more details we need to look at on multiplying. And one of those things is handling variables. So here's one. The square root of x squared. Now we've talked about before how a square root and a square cancel each other out, and all you get left is whatever was being squared. So that's still true even if we have a variable, because after all, a variable is just a number that we don't know. So we can assume that this x is positive. Most of the time in your instructions you'll notice a little thing that says assume all variables represent positive quantities. And that's so that we don't have to worry about absolute value bars, and we just assume that x is positive. And same thing goes here. So the square root of x to the 6th, we're looking for something times itself that gives you x to the 6th. Well, x to the 3rd times itself gives you x to the 6th, because 3 plus 3 is 6. But now notice the pattern. Here my exponent is 2, and then the square root is 1. Or the exponent is 1. Here my exponent is 6, and for the square root, the exponent is 3. So it cuts it in half. So every time you do a square root, it just cuts the exponent in half. So now it's easy. Square root of x to the 10th is x to the 5th, now that you know the trick. And the square root of x to the 120th would be x to the 60th. But now, I know you're already asking, and I know you see it here, what about odd powers? That trick works great as long as the number exponent under the radical is even. But what if it were odd? In that case, what you want to do is separate your x power with your even exponent into two pieces. So it's going to be x to the, like for example, be x to the 9th. We could split into x to the 8th times x. So this is still x to the 9th, because 8 plus 1 is still 9. But what this does for me is it makes it easy for me to take the square root of x to the 8th. So using the product rule, I split this into two radicals. The square root of x to the 8th is x to the 4th. And the other x, the odd one, stays under the radical. So here's just another example for us. We're going to split x to the 15th into two pieces. X to the 15th would become x to the 14th times x. Make two radicals out of it, and then half of 14 is 7. So the square root of x to the 14th is x to the 7th, and this x is still under the radical. Now let's divide. So when you divide radicals, what I want you to do, instead of starting off simplifying the radicals right away, combine those radicals into one fraction that's under one big radical. Then you can simplify the fraction, which will be easy, and then you can simplify the radical. But that's much easier than trying to simplify the radicals first. You'll see that that other way just makes a mess, and this way is much easier. So always push it together into one big fraction, simplify the fraction, then the radical. Okay, now simplify. Square root of 48 x to the third over the square root of 6x. And your first impulse might be, well, I can simplify square root of 48x to the third. But if you do, you'll have a mess on your hands. What I want you to do is make this all into one big fraction that's under one big radical. Because this fraction is going to be much easier to work on than the radicals. So let's reduce 48 over 6 makes 8. And x to the third over x makes x to the second. Okay, now this radical is a lot easier to simplify than the ones we started off with. So 8 is 4 times 2. And the square root of 4 is 2. And the square root of x squared is x. And the only thing still under the radical is this 2 right here. Here is another similar example. So I've got square root of 150x to the 9th over square root of 2x to the 5th. Do not start trying to simplify this radical because it just makes it harder. Start off by putting everything together under one big radical, because that gives you a fraction that you can simplify. 150 over 2 is 75, and x to the 9th over x to the 5th is x to the 4th. Now we can simplify this radical. So 75 is going to be 25 times 3, and of course we've got x to the 4th there. And since x to the 4th is an even exponent, it'll be easy to simplify. So the square root of 25 is 5. The square root of x to the 4th is x to the 2nd. And this 3 will be the only thing that stays under the radical.